Welcome back. Finally found some time to film the lithium battery build. Apologies it's taken so long. I've been in between moving house and renovations and the business and everything. It's just been manic, so yeah, finally found some time, so let's crack on. So if you haven't seen the previous video, I purchased everything you need to build your own 100 amp hour lithium battery, but using all good quality parts. And these are EVE cells, 3.2 volts each. And yeah, we got all the kit for under $600 delivered. So basically the next is to build it and test it and give it a hard time and see how well it performs compared to a similar priced or cheaper alternative that you don't know what you're getting sometimes. So compared to the big boys that are over $1,000, yeah, it was just a little challenge. So let's see how we go. So basically these cells have been sitting here for 3 months now. So the first thing I want to do is just check the voltages across all four. I'm not gonna top balance these. Basically the reason being is I want to build this so anyone with basic tools can attempt the same without having special equipment. But a few of you have made comments about just connecting each of these cells up together in parallel just to balance them naturally over 24 hours. So we're going to do that. Yeah, and then we'll continue with the build. So we'll check the voltages across all four and see how they've sat. I'll pop you up here. All right. So number one, 3.24, 3.25, flicking between the two. 3.24, 3.24, 5, flicking between, 3.25. So they're all pretty close. But what we'll do next is we'll join them all up in parallel and let them naturally balance themselves, and then we'll crack on. Okay, so these are the cells. Doken Power, the supplier, 3.2 volts, 100 amp hour. So we'll balance these up. Already had these leads made up, so they're all the same size cable, same size, same length. So we'll just connect them all in parallel. Close them up. Alright, so they are now all connected up in parallel, and we'll leave them for 24 hours and let them do their thing, and then we can crack on with the build. Speak to you soon. Okay, so the plan was to balance these cells over 24 hours, 48 hours. It's actually been 6 weeks since I've done the first section of the video. I've been so busy leading up to Christmas, so it's actually the 22nd of December right now. I've literally just finished work on the Friday, so I thought, well, let's crack on with this while I've got some time. So yeah, so basically we'll just check 3.25 volts, 3.25 volts, 6, 3.25, 6, 325, 6. So they're all even, which they should be because it's been bloody ages. So what we'll do next is we'll take the leads off. I've made up some leads for the BMS. I don't know why, but they didn't actually come with any leads, so I've just made up my 2 negative leads and then my single positive. These are 6 BNS cable rated at 125 amps, continuous. You would expect 100 amps. I'm not going to max this battery out, so yeah, the battery cable should have been slightly larger, but this is all I had. And this is purposely a build for light use, so I'm not too stressed about that. So yeah, we'll get on to strapping up the cells next, and doing all the wiring. So let's crack on. All right, leads it off. So next step is to change it from a parallel configuration, just ease for when we're balancing the cells, into a series configuration to increase the voltage from the 3.2 up to the 13 volts that we need. So first thing we do is just double check, always check your cells, make sure there's no visual damage, make sure they haven't swollen or warped or anything like that. These are all in really good shape. These are Eve cells, meant to be grade A, brand new cells, and they seem pretty good. So the next step is to swap them round. So what we want to do is swap that one round, then we'll swap that one round. So now this is going to be our main negative out. This is going to be our main positive out, going up to our battery. Negative, positive, negative, positive. But before we put the bars on and connect them up, we will just want to put some divider sheets in, and we need to tape them up together, kind of like for compression. Some people say you have to set a certain amount of pressure into them. I'm just going to use some really good quality tape, because I might change this setup down the line. I don't know, this is just basically for testing purposes, to see how it performs, and we might expand it later down the line. So I'm just going to tape them up for now. Now, I've done a bit of research, and a lot of people use the Captain tape. Over here in Australia, the closest I could find is the polyamide high temp tape. Basically, this is very good quality, bloody expensive. This was $17 for this. So yeah, hopefully it goes a long way. I doubt it. So what we'll do is we'll tape up the cells as they are, and then we'll do all the wiring. So we'll crack on to that next. Alright, so we'll grab our little divider sheets. I don't know if these actually do anything, but they came with the kit, so we might as well use them. So we just need 3. Nice, and then we just tape it up. That'll do for now. Like I say, I might change it down the line, add to the system, so I'm not too fussed about that at the moment. This is purely for demonstration purposes. Alright, So we want to grab our buzz bars. So this is going to be our negative out, positive out. So we want to connect that one to the second battery, positive to negative, and then we want to go positive to negative there, then positive to negative there. So we'll bolt these up now. Didn't mention these have got a little they're groove basically, so it allows a little bit of movement for the studs, which is pretty cool. But we're going to knit these up now, and then we'll get onto the wiring. Now, don't go too tight. These are not too bad because these have got the studs. It's when they've got the recessed threads, they strip out so easy. But on these good quality cells, you've got the nice welded studs, so you're pretty safe, but you ain't got to go mad. There's probably a torque setting for this, but we'll just go with gut. Alright, so now just double check our voltages. We should have 13 volts. Whee, 13 volts. Alright, so the next step is to wire up our BMS and see if it actually works. So let's move on to that. Okay, that's all bolted down. Let's move on to the BMS. So this BMS here, here's the part number. It's a JK-B1A 8S10P. It's a 100 amp BMS with Bluetooth, which is pretty cool. These are our two temperature sensors, our high and low cutoffs. So everyone does it differently. To me, I think it makes sense that we do one of the temperature sensors on number 1, and then the other sensor on number 4 cell, and just tape them to the top or to the side. I'll probably just tape them to the top. Then we'll move on to this 11 pin plug here. So on this one, it gets a little bit tricky, but once you figure it out, it's all good. So you've got a single black right there. This needs to go on to B minus there. So that is our B minus. So this goes on to our main negative stud of our first cell. Then we've got B1, B2, B3, B4, right up to B8. Now, because this is only 4 cells, we won't be using 5, 6, 7, 8. So we'll use them. And these basically just go on to each positive terminal of each cell in order. That's it. But what catches a lot of people out is on the very last one here, you've got a B plus, which you'd think it'd be a B9, but it's a B plus. And this goes onto our positive of our final stud, our main positive out. So don't be cutting that one. You can cut the cables that you're not going to use off. I've just coiled them up because, again, I might expand on this system at a later date. So I'm just going to connect up what needs and then tape up the rest. The leads are to, I'd say 500 mil. You can cut them down. People say that that alters the resistance and the way it measures each cell. Whether it's true or not, I really don't know. But for me, I'm just going to coil them up. I'm going to keep them all the same length, how they come, and just put them onto the cells and then tape up what we're not using instead of cutting them down. Like I say, I can't see it being a problem cutting them down, but I'm just going to leave them where be. So we'll connect up all the balance leads first, and our negative in. So on this one, you got a B minus and a P minus. our B minus is our two negative leads going to the first cell of our battery, and then the P minus is going from this BMS up to our stud on the battery case. So the negative runs through the BMS. Really simple. So we'll do that next. Alright, so I've just crimped on our little ring terminals, and then for our B4 right there and our B plus, put them onto one terminal because they're all going to our positive right there. So we'll connect it all up now. So there's our main lead. Like I said, I made up these leads for the money. They didn't come with any leads or any case or anything like that. So yeah, which I thought was pretty poor. So, but there you go. So lucky enough I had some spare cable. So we'll bolt these on, connect them up, and then we'll just connect up each cell and go from there. Right, man, it's hot. What's the temperature today? Look at that. 47 degrees in the workshop today. It's about 36 outside. Crazy weather. Alright, so let's crack on. So I've just screwed in my B minus. There's probably a torque setting for these, but I just done them as tight as I could go to what I think is correct. Alright, so this wants to go on the negative of your first cell, along with this one, if I can get it out, our B minus. So we connect that on, chuck a nut on there. I'll just nip it up for now because I don't know how the cables are going to lay once they're in the box. Alright, so that's that one. Now we want to get B1. You can't really see. So now we want to go for B1. That one right there between my fingers. So this one, if I can pick it up. So this is going to go onto our positive of the first battery, and then so on to each cell, each positive of each cell. So we'll do that next. B2. And B3. And B4 and our B plus, along with our main cable. Sure. Beautiful. Alright, just going to tidy up this wiring, make it a little bit neater, and then we'll continue. Alright, not very neat, but it'll do for now. So I've just taped up my leads going, let me show you better. So there's our cell 4 and our B plus going to our final positive terminal, and then you've got your main negative coming from B minus, and then our B minus on the first, and then each line B1, B2, B3, B4. So now we are active balancing all the cells. So next I want to just connect up our main terminal into our case, just so it doesn't touch anywhere. I'm not going to do the temperature sensors until it's in the battery case. I've got loads of room in there, so I'm just going to double side tape this to one side of the for the case. Like I say, I'm going to change all this out later, might add to the system, so I'm not too stressed. So what I'm going to do here is, the case that it came with has got our threaded connection points. I've got some stainless steel bolts that I'm going to put through this cable on the inside and come through, so then I've got a stud to connect all my consumables onto, accessories onto, once it's all built. So we'll do that next. Okay, so just bolted the main positive on, just got a little stud right there. Great camera action, Matt. There you go. So that's that. Now, before we power up the BMS, I just want to double check the wiring. So I'm just going to go through and make sure. So we go onto the B plus, onto our main negative. We've got 13 volts. Then we'll go on to B4, which we should have 13 volts. Then on B3, so that's cell 3, we should have 9 volts. Then it should go down to 6 on B2, and then 3 volts on B1. Then we'll switch these round, and then we'll go on to the B minus. So that just confirms that all the cables are correct, so that's awesome. So at the moment, if we check, BMS is connected. So 0.13 volts from the positive to the negative of the BMS. So we just need to wake it up. Now, some of the BMSs on this port here have a little remote switch on off. This didn't come with it, so I'm presuming if we put the charger on it, it should wake it up, and then we can, I've already downloaded the app, then we can search for it on the app. So we will connect that up now. We'll go on to there, and we'll recheck the voltage. 14 volts. So that's kicked the BMS into life. And I don't know if you can see that, now we've got flashing light. So we'll get these out of the way. And right, there's the app. Scan. Go, click on that one. Something's just bleeped. Please input password. I don't know the password. Let's just go 1, 2, 3, 4. Pair. There you go, that was a good guess. Alright. So, what have we got here? So we've got 13.06 volts. Battery capacity. So what I'm going to do is I'm just going to go through all of these. There's our 1, 2, 3 and 4 cells, all reading exactly the same. That's nice. So I'm just going to set it all up, basically tell the app the capacity, so it can read correctly, and then we'll run through it all. Okay, so I've just gone into advanced settings, just making sure power voltage, our charge current is set to 25 amps, discharge current 100 amps. So that's, I'm going to leave half of this alone. So once you're ready, you just press OK. With that, then we want to go to control. Now balance is on, and then we want to charge it. It's still on the mains charger. We don't want to just disable the temperature sensor. Leave that well alone. Then, so there you go. We've got 13.1 volts and we've got 9.5 amps from the charger going in. 100 amp hour, and our cells are all pretty close in balance, so pretty happy with that. So next stage is to put all this into the box. Then we're going to run through some tests. Usual tests with what I do is connect it up to my fridge, run it for a few days, see over how many days, how many hours it will run for, using my my digital shunt, and just continue doing that and just see how well it performs for what we paid for it, and we'll go from there. So awesome. All right, I'll put it all in the box and we'll get back. Okay, so the cells are in there. I've just used some Velcro tape for the BMS. Again, I don't know if I'm keeping this set up, so I just want to make it easily undoable if need be. The cells are in there. I've just put some foam in there to support the cells and to stop it moving back and forth, and negative cable is on my case. So we're not going to glue this case down or anything, we're just going to place it on top. There you go, with our studs. So what I've got to do now is I'm going to put this on my 10 amp charger. We're going to charge this for 24 hours to get it right up, because at the moment, as you can see, 13.17 volts. There's our capacity, 100 amp hour, and the remaining is 67 amp hours. So we're going to charge it up to 100, then we're going to connect the fridge up to it, and then just see how long it runs for, like the test we normally do, and yeah, and go from there. And you can see all our cells are really nicely balanced. I'm really happy with that. So yeah, we'll come back tomorrow and go from there. Cheers. So battery charger is finished. It's in storage mode now. It's been about 18 hours, under 24 hours, but I'm pretty keen to get the next test up and underway. So you can see there, 13.52 volts. There's still 1.2 amps going in. All our cells are pretty much even, and battery capacity, remain capacity 100 amp hours. Just double check all the settings. There's all our settings, advanced. I haven't changed any of these. Even the charge current is 25 amp. That's standard with these apps. Some people like to use larger chargers. I just use a 10 amp charger, which is absolutely fine for me. So I'm just going to leave that as 25. Everything else I haven't changed. So what we're going to do next is plug it into the fridge and run it through my separate digital shunt and see how long it lasts. So yeah, thanks for watching. We get on to the next one. Please like, subscribe and comment. Anything I should have done better, or any hints and tips, that would be great. And yeah, we'll get on to the next one. Cheers.